Hello, everyone. My name is Mauricio Velasco, and today I want to present to you msInvader, a tool that can help you simulate adversaries within M365, Azure, and Entra ID environments. Let's start with a quick introduction about myself. I'm originally from Arequipa in Peru, and I'm currently a security researcher within Microsoft Security and AI Group. I'm still on X or on Twitter, where I share interesting research by other people, by myself. So if you're on the platform, do follow me. And finally, that's my GitHub account where I've post the tools I write, the talks that I posted. So if you're interested about adversary simulation or detection engineering, do visit my GitHub. But all right, let's go ahead and start. Before we start, just a quick disclaimer. Today I'm hosting this session and releasing this tool at a personal capacity. I'm not representing my employer. So let's start talking about the cloud threat landscape. I think moving to the cloud has changed how companies work, and it also has changed how attackers operate. As more tools and data live in the cloud, attackers are following them. And we're seeing a big shift in how modern attacks are happening. There's often no malware, no files dropped, no need to touch a single endpoint. Instead, one stolen OAuth token can give attackers access to emails, files, even admin tools without sending any ADR alerts. I think this turns things upside down a bit. Endpoint used to be the easiest target, but now they're locked down and closely watched. For cloud platforms, well, they often have weak login, few detections, and a lot of places to hide. So let's take a closer look at that shift and what that means to defenders. I think that what that means to defenders is that we need to redefine visibility. We're in a moment where traditional endpoint isn't the primary target anymore. Attackers are going to go after what we trust the most, identities. If if they get a valid token, they don't need to drop payloads or touch disk. We spend a lot of time improving our visibility on endpoints. Attackers have realized that and are um, going after new methods. And once they're in, everything they do happens through APIs. They don't need remote shells, lateral movement tools. They're simply cloning APIs like the Graph API or Exchange Online, and they do it all from the infrastructure that looks legitimate. In in on-premise environments, we've had years to learn how attacks look, what a malicious process or a binary looks like. But in the cloud, defenders are still building that intuition. What does a malicious OAuth activity look like? How do you detect abuse of a service principal? I think there's still emerging questions, and attackers are a bit ahead of us. So what do I think defenders need? One we need many things, but I think one of the things that I think is important is that we need to get our hands on ways to replicate these techniques safely in our environments, in our lab environments, in our test environments. We need tools that can simulate real attack behavior post compromise, that can generate the right telemetry and help us validate whether detections and response workflows are actually working. And that's why I built msInvader. So, what is msInvader? Well, msInvader is an adversary simulation tool designed to execute attacker techniques against Entra ID, M365, and Azure tenants. The goal is to generate attack telemetry that can help defenders improve detection and response capabilities. msInvader leverages APIs just like attackers do, like Graph API, Exchange Web Services, Azure Resource Management, for comprehensive simulations and technique variations. How does msInvader work? Well, at a high level, first, msInvader needs to authenticate to the Microsoft Cloud in order to simulate these techniques. Um, and for this, we are interacting with the Microsoft Identity Platform, which uses protocols like OAuth 2.0 and OpenID. So essentially what msInvader is doing is implementing what are called OAuth at grant flows to obtain tokens in the context of users, in the context of service applications, service principals. So once we obtain these tokens, then we can interact with the APIs to start simulating some techniques. And what are all the ways that msInvader supports token acquisition? Well, there's multiple. For example, if we want to simulate attackers stealing credentials like phishing attacks or password praying attacks or keylogger attacks, well, we can use the resource owner password credential OAuth flow, which allows us to obtain a token with a username and password. Now, if a particular tenant has configured MFA where this OAuth flow is no longer possible, and we want to be able to simulate other attacks like adversary in the middle, token theft, or MFA fatigue, or even device code phishing, we can use the device code OAuth flow, which allows us to obtain a token by submitting a code in an interactive way. And finally, if we want to simulate the compromise of a service principal, um, secret, or certificate, we can use the client credentials flow. This is an OAuth flow that allows us to obtain a token for a service principal. So this way, msInvader is able to obtain tokens by simulating these potential attack scenarios, breach scenarios. This is how the device code flow looks like, and we'll see that in the demo in a bit. Now, once the token is obtained, we need to interact with the Microsoft Cloud. Well, we can do this by leveraging multiple APIs, like the Graph API, Exchange Web Services, Azure Resource Management API, Security and Compliance API. My goal is to be able to interact with as many APIs as possible so we can have a larger action space. And msInvader leverages a configuration file. It's a flexible configuration file where you can configure playbooks, attack simulation playbooks, and define techniques, steps, and multiple parameters for each technique. At a high level, the structure of is two. We have two sections: the authentication section, where we describe details about the tenant, and then the simulated compromised users or service principals that we're going to use. And finally, the playbook section, where we define all the techniques that we want to execute. So we can run end-to-end attack simulation playbooks. All right, that's it for the introduction. So let's move on to the demos. So let's talk about a threat actor called Storm 2372. I saw this interesting report on a Microsoft blog post. This report is from February this year, and this Russian tied actor is targeting 365 environments. And once again, they're not leveraging malware anymore. So they get in by implementing the device code phishing technique to steal auth tokens. This way they can bypass MFA. Once they obtain a token, their access is fully API driven. They're leveraging the Graph API to search and exfiltrate emails and directory data. And they also using this API, same API, to move laterally by sending malicious emails to other users in that tenant so they can potentially compromise more accounts. All of this, once again, without touching disk, without a single malware campaign. At a high level, based on the report Microsoft released, these are the main high-level steps: device code phishing, email exfiltration, in email lateral movement. I wanted to take this interesting report describing the techniques executed by Storm, this threat actor, but I wanted to expand on it. So that's why, kind of like extending this threat actor, I designed this simulation playbook where we are adding a few things. After device code phishing, we'll do tenant enumeration, so discovery. Using the Graph API, we can discover users, groups, etc. Then we'll go ahead and do email exfiltration, and we'll add a new technique, file exfiltration, because with the Graph API, you can also interact with OneDrive. So why not exfiltrate files as well? As a persistent mechanism, we're going to create a mailbox rule on that mailbox. So perhaps the attacker can monitor that mailbox and steal information. Finally, we'll execute the email lateral movement technique by sending malicious emails to users. This is how the playbook looks like from an msInvader technique perspective. First, we'll do the device code phishing to obtain a token. Then we'll enumerate users using the Graph API, enumerate groups, enumerate applications, directory roles. These enumeration techniques will provide the attacker with a lot of information about the tenant that can help in future attacks. Then we're going to read emails. So we're going to exfiltrate the first 10 emails on that mailbox using the Exchange Web Services API. Then we'll try to mimic what the attacker did on like the report. We're going to search for particular keywords using the Graph API on this user's mailbox, on the compromised mailbox. In this case, we're going to search emails that contain the contract. Well, I seem to have repeated it here, but you get the idea. We're searching, we're going through the mailbox, searching for emails. And now finally, we're going to search OneDrive by looking for files that contain certain keywords. Finally, we're going to create a mailbox rule using the Exchange Web Services API. We're going to create a moving rule, which will move an email based on a criteria. And finally, we're going to simulate lateral movement by sending malicious emails to other users in this tenant. All right, so let's go ahead and move to the demo. Okay, bear with me. Okay, so we have our simulation tenant where we have a bunch of users, we have resource groups and Azure resources, we have 365 and we have 3 licenses. And then we have login as well with Azure Analytics Workspace and Sentinel. So let's go over at a high level. This is the playbook. I'm not going to go over all the details since we've already been through it on the slides, but we are going to start with a device code for this user, Clark Kent. This is our simulated compromised user. And these are all the techniques that we're going to execute, like enumeration using the Graph API. Then we're going to start reading email using EWS. And then we're going to start searching for email, searching for OneDrive files, creating that rule, and then finally sending emails. So this is the simulation playbook that we'll run to try to simulate the actions taken by Storm, this threat actor. And we have our simulated victim here. Here, as you can see, has a bunch of emails and has some OneDrive files as well with secrets. Okay, so let's go ahead. So in order to simulate device code phishing, we're gonna have to authenticate as a compromised user. Of course, in the real world, attackers will actually send a phishing email, try to target that user, but we don't have to do that. We can just simulate the actual device code part. So we're going to go to device login page as that compromised user, trying to simulate that particular user falling for this phish, and we'll submit that code that msInvader gave us. This actually bypasses MFA, but once this works, msInvader will have a token as that user, and then start enumerating. Enumerating 26 users and found 10 groups. And this is going to take a bit. So let me pause this so we can come back real quick. So as msInvader is about to finish, let's go over at a high level. First, as we saw, it performed a bunch of enumeration, found users, applications, directory roles. Then it read emails from this compromised user. It read these 10 first emails and actually accessed the body. Even though I'm not printing them, we access the body and generate those logs. Then we start searching for emails that contain keywords like password. In this case, it found 2 emails with the keyword password and then 2 emails with the keyword credentials. Then it goes through OneDrive enumeration and exfiltration. It searches TeamViewer for TeamViewer, and as you can see here, it actually downloads. It should have downloaded these files. There you go. These are all the exfiltrated files in an automated way based on those keywords. Finally, it added a new inbox rule for that user. So we see in this user, if we refresh here, we go to the rules, we should see a new rule created that may potentially be some kind of persistent mechanism to perhaps steal information from the user. Here's the rule that was created, and this rule will forward any email that has the body invoice to this attacker control email. And finally, it tried to move laterally by sending malicious emails. And this is the malicious email that it sent to other users in that tenant. Okay, so that was playbook number one. Now, in terms of the log insights after we ran the simulation playbook, as we walk through this attack, there's three data sources that can help us trace every major step. Signing logs that tell us how the attacker got in, and there's a particular way of finding device code phishing just by looking at a particular field within this table. The Microsoft Graph activity logs let us see what the attacker did in terms of enumeration by leveraging the Graph API. And finally, the Office activity table that essentially captures the M365 logs related to email, to files, so we can see exactly what emails were accessed, what files were accessed. All right, let's move on to the second demo, keyboard lateral movement. So in traditional environments, lateral movement might happen from one workstation to another using tools like PSExec or Impacket or RDP. But in cloud environments, it's going to look very different. There's no shell, there's no malware, once again. So instead, attackers are going to abuse over permission users, misconfigure roles and services to move laterally between services. This kind of movement happens entirely through APIs. And because it uses legitimate services, it's harder to detect. So this is what we're going to simulate in this scenario. In this scenario, we're going to simulate a password spray attack against our tenant. That's going to provide the attacker with access to one account. That account is going to do some MS Graph enumeration. Now we're going to introduce ARM enumeration to enumerate Azure resources. Um, and we're going to, in this simulated scenario, we're going to assume that this user has a particular Azure role, the key vault contributor role that allows this user to manage key vaults. Something interesting about this role is that it doesn't allow the user to view the secrets of the key vault. However, it does allow the user to create a new access policy that to grant themselves access. So this is what we'll do. We'll do key vault exfiltration by first creating an access policy to obtain and then dumping the secrets. And in this simulated environment, the secrets in this key vault is actually the secret for a service principal. So we'll log in as that service principal, and that service principal has the permissions to exfiltrate emails. So this is our simulated scenario that we'll execute with msInvader. So once again, these are the steps at a high level: password spraying, graph enumeration, ARM enumeration. We're gonna list key vaults. We're gonna try to access a key vault. We'll get an error because we don't have access. So that's when we'll create an access policy and try again, and that will give us access. With that secret that we find on that key vault, we'll authenticate as a service principal, perform a little bit of enumeration, and then read emails, exfiltrate emails from our tenant. All right, so let's go to the next demo. Here's the playbook for the second demo, where we start with a password spray, start with a bit of ARM enumeration, then we list key vaults. We try to access the key vault. Then this is where we add an key vault access policy. And as you can see, this technique, you provide certain parameters to create that. And then finally, we get access to the secrets. We do some enumeration, and then we exfiltrate emails using that service principle. Now, how does this look like from a simulation environment? As you can see here, we have in this resource group, we have this key vault. This key vault contains a secret, and at the moment, it only has one access policy. And as you can see, our simulated compromised user, Peter Parker, is a key vault contributor. Okay, so let's run our second demo. So we start with the password spray to generate some logs. And let me pause this video so we don't have to wait, and we'll come back once msInvader is finished. Okay, so let's go over the logs. So after the password spray, um, it found the valid credentials for Peter Parker. Then we start with the enumeration, ARM enumeration. We find a bunch of resources, a bunch of key vaults, as you can see here. Then it tries to access a particular key vault. And of course, there's no permission because a key vault administrator contributor doesn't have permissions to print secrets. So we'll get that. And then it's going to try to add an access policy, which was successful. And we can validate that by refreshing here on the access policies. And we should see that a new access policy was created. Now Peter Parker has access to the secrets. Moving on, we now try to print and we actually find a secret. And this is the secret for that application registration or service principal. So msInvader will authenticate to that service principal, will enumerate, and will ask that service principal enumerate that we have this app role. And this app role it's the Graph API application permission that allows the service principal to read any email. And so the final step is to exfiltrate emails from 3 different users. Clark Kent, we read 10 emails, Peter Parker, 10 emails, and finally Tony Stark, 10 emails. And that concludes this end-to-end simulation playbook. Going back to the logs, on top of the logs that we mentioned before, we can mention 3 more tables. AAD service principals signing logs allows us to capture signings by service principals. Azure Activity can track control plane actions like role assignments, access policy changes, and the Azure Diagnostics table can provide us specific resource level activities such as key vault, secret reads, secret listing, etc. So that's the end of the demos, guys. What are our takeaways? I think that the goal of simulations like the ones that msInvader allows us to execute is not just to mimic an attacker, but it's to learn from the telemetry. You start to see which logs are useful, which ones aren't there, and your blind spots, and you can check your blind spots. This kind of visibility helps us drive real detection engineering. You're not writing rules in a vacuum. You're responding to actual techniques you've simulated in your own environment. And finally, I think that simulations are a great way to challenge assumptions. You might think that you have a control that will block or detect certain technique, but until you test it, you don't know. So I think these type of simulation exercises can help us validate if your defenses behave the way you expect. So that was msInvaders, everyone. Thank you for attending this session, and I hope you have a great day. See you in the next time. Bye.